So we are in Unit 5, and we're actually doing Section 5.4 in our textbook, but it's Target 2. So our Target 1 was doing derivatives and integrating natural log. So now we're going to do the derivatives and integration of e, exponential functions, e to the x. Okay, so our outcome, which is really Target 5.1, is I can differentiate and integrate problems involving the constant e, exponential functions. All right, so we've already talked about natural log of x and how to do derivatives and integrate those problems to get natural log. So the inverse of natural log is the function e to the x. So that's why we're studying these together, is because they are inverses of each other. They undo each other. So e and natural log are opposite operations. All right, and this is what e to the x looks like. Okay, it's what this function looks like. E follows the same rules as other laws of logarithms. When you multiply powers, you add, and when you divide your powers, you subtract your exponents. So E follows the same rules. So exponential functions follow the same rules as any other exponents and powers. So we've already studied how to take the derivative. Remember, e to the x is its own derivative. Okay. So when you do just the derivative of e to the x, so if you had y equals e to the x, then y prime is e to the x, because e to the x is its own derivative. Over here, what if we don't have just an x? What if we have e to the x squared? It's not just an x, it's more complicated. Then you still have e to whatever your function is, but then you have to chain on the derivative of the exponent. So here, our derivative, you keep it, e to the x squared, but then you have to multiply by the derivative of x squared, which is 2x. So just remember, if your exponent is more complicated than just an x, don't forget the good old chain rule. We have to chain on the derivative of our exponent. So we've already studied that part, taking the derivative. So what's new in this lesson is integrating. So since e is its own derivative, then it makes sense that the integral of e is also e. So if you're doing the integral of e to the x, it's going to be e to the x plus c. And that's only when the exponent is an x. Now, what if your exponent is not an x? What if your exponent is some other function? Then you're going to do a u substitution. So we are going to let the u be the exponent, and we're going to do u equals whatever that function is. And then we're going to do our du, which will be the derivative, and then dx. And then you're going to solve for dx. So it'll be du divided by whatever that derivative is, and then you're going to do a trade out, okay? So you're going to end up doing u substitution when you're doing e to some other expression that's just not an x, all right? So it's going to come quite natural since we've been doing some u substitution, all right? So to keep on going just a little bit and split this video up a little bit before I do the examples, we're just going to do the general examples and the derivative examples with this content part. All right, so just reviewing how to do this. How do you solve an equation like this where the variable that you're solving for is in the exponent? Well, you have to get it out of the exponent, and the only way to do that is do logs, right? To get the exponent out of the, or get the variable out of the exponent, you have to do logs so that you can multiply that power to the front. And since I'm doing an e, I'm going to do natural log. So I'm going to take the natural log on both sides. All right. So now that I've done the natural log on both sides, I can use a law of logarithms and multiply my power to the front. So that's going to multiply this quantity to the front. Just take that whole quantity and multiply it to the front. Now when you do that, the natural log of e is 1, so this goes away because that equals 1. So then I just have the natural log of 7 equals x plus 1. So when I subtract 1, I get the natural log of 7 minus 1 equals x. All right, so there's my answer for x. Now, this is not the natural log of 6. It's the natural log of 7, whatever that is, and then you subtract 1. All right? So that's the answer for x. So whenever you're trying to solve for the exponent, a variable in the exponent, you've got to take the log. So in this one, it's just the reverse, all right? So now that I've got the natural log and I'm trying to solve for x that's inside the natural log, I now need to use e. And there's two ways to do this problem. All right, they both end up the same way, but there's two different ways of thinking about it. One thing you can do is you can raise these both to an exponent of e. So you can raise both, make these the exponents. So it would be e raised to the natural log of 2x minus 3 equals e raised to the 5. So you can make these two expressions be your exponents. So you would move them both to the power of a base e. Now, when you do that on this side, these two are going to cancel because e and ln are inverse operations. So these are going to cancel each other out. So you're going to get 2x minus 3 equals e to the 5. And then you're solving for x. So 2x is going to equal e to the 5th plus 3, just adding that 3 over, and then divide by 2. So your answer is going to be e to the 5th plus 3 divided by 2. That's our answer. Now, the other way to think about it is to think about what does this mean, this logarithm. What is a logarithm? Well, this means we're in base e, so natural log is base e. So e, let me change my color. E raised to this exponent will give me this answer. So e raised to, because remember a logarithm is an exponent. So e raised to the 5th power is going to equal this stuff behind the natural log. That's using the definition of what logarithms are, okay? So whatever base we're in, so remember if we did these before, just a regular log, say log base 2 of 8 equals 3, that means 2 to the 3rd equals 8. So that's converting from a logarithm into an exponential function. So that's what I'm doing here. I'm converting from a logarithm into an exponential function. So it's your base raised to this exponent gives me this answer here behind the logarithm. So base raised to exponent gives me this answer. So natural log is e, so e raised to 5 as an exponent equals this answer of this expression in the parentheses. So e to the 5th. And then I'm solving for x. So I add 3 to the other side. And then I'm dividing by 2. Notice you get the same answer. So exactly the same answers I got over here. So it just depends on which avenue you want to use to get there. You either raise both of these as exponents on e, or the other way is to use the definition of converting between natural log back to an exponential function, that it's this base raised to this answer exponent will give me this function, okay? So it just depends on which avenue you want to go to get to the answer, all right? So that's just talking about natural log and e being inverses of each other. All right, so let's do some quick derivatives. These we know already, so I know you were really good at doing these derivatives. So if f of x is e to the 2x minus 1, then the derivative f prime is going to be the same function, e to the 2x minus 1. And then you have to chain on your derivative of your exponent. So then you have to multiply by the derivative of 2x minus 1, which is just 2. And you can always put the 2 in the front. So you may see it written this way. 2 times e to the 2x minus 1. All right, over here in part B, f of x is e to the negative 3 over x. What you might do here is rewrite this because you know you're going to take the derivative. So I might write this as negative 3 e to the negative 1. Or, excuse me, I didn't write that right. Negative 3 x to the negative 1. So you're just bringing this x upstairs and making it x to the negative 1. So I'm just rewriting negative 3 over x as negative 3 x to the negative 1. So now when I do the derivative here, f prime of x, the derivative is what you see, e to the negative 3 x to the negative 1. But then you have to chain on, multiply by the derivative of your exponent. So if I take the derivative of this, that's going to be negative 1 times negative 3, which is 3. And then I'm going to subtract the power, be x to the negative 2. And if I rewrite it, that's e to the negative 3 over x. And then this is times by 3 over x squared. So just remember the derivative of any time that you take the derivative of e, it's all of the stuff you're looking at, all of that e raised to that power, and then just multiplied by the derivative of its exponent. That's how you take the derivative of e. And I know you thought that was really easy last time, so it shouldn't be any problem this time. So the new thing we're learning this time is how to integrate, how to go backwards. So the derivative of e to some function is e to that function multiplied by the derivative of the exponent of the function. So that's how you take the derivative of e. Okay? All right, so that's the end of that video. In the second video, we'll do all integration.